Alright, welcome to this video about solving equations. We're using a different way to solve equations this time. As you can see, our goal is to solve equations using multiplication. Alright, we have done addition and subtraction. Most recently, we've done division, solving equations with the division. Our goal for the end of this video is to solve equations using multiplication. So it's our last inverse operation that we're going to use. All right, so quick review. We talked about inverses and inverse operations. The additive inverse, we said, was the opposite number. So if you say you have example would be if you have 14, additive inverse. Well, what would the additive inverse be? Remember, it is the opposite number, and the neat thing is, they always add up to 0. So the additive inverse for 14 would be negative 14, because 14 and negative 14 add up to 0. If you add them up, look at the number line 14, and then you add negative 14, that's going back 14 all the way to 0. It's basically the opposite number. In just a little bit, we're going to talk about the multiplicative inverse, but I wanted to review this one and show you how they're actually different. All right, so this is a great review for some of us. Solve x plus 10 equals negative 65. And I actually like to see your work. In my opinion, the work here, the process of solving, is more important than the answer itself. Okay, you need to understand these processes and be able to follow them. So, first of all, you have x plus 10 equals negative 65. We're looking at the left. The very first step that you should always think about is, what variable am I trying to solve for and isolate? In this case, we're looking at the x. Put a nice box around it so that stays there. But to isolate it, it has to be all by itself. And it kind of says here, since 10 is being added to the variable, we want to subtract that 10 from both sides. We don't want that 10 on the left side anymore. And if we subtract it from the left side, like I'm doing right here, to keep this equation balanced, you also have to do it to the right side of the equation. When I say left side and right side, it's just left side of the equal sign, right side of the equal sign. All right? So note that subtracting 10 is the same thing as adding a negative 10. Right? We've talked about that. It's the same thing as adding a negative 10. Those two are interchangeable. If you wanted to subtract something, it's the same thing as adding a negative. Right? So here's the work. When you subtract 10 from the left side, that gets rid of everything. That's the additive inverse. 10 minus 10 gets you to 0 on the left side, so you're just left with that x. And negative 65 minus 10 gets you to negative 75. So again, they're both negatives. It's going farther into the negatives. It's like it's negative 65 degrees outside, and it's dropping 10 more. It's down to negative 75. Oh, I sure hope that doesn't happen this winter, though. Anyway, so we're saying that x is equal to negative 75, and that's our solution. That's what we're looking for. But you can check that a couple different ways. Well, really just one different way. To check, substitute the solution 75 for x into the original equation. Okay, that's a very important thing to note. I will highlight that because I think that's so important. So again, to check, substitute the solution negative 75 for x into the original equation and simplify. All right, so you can do that right where we're looking at right here. Instead of x, we're using negative 75 because we said they're equal. So negative 75 plus 10 is, in fact, negative 65. And so that is our solution for negative 75, because negative 65 is equal to negative 65. So we're good there. Then we can give ourselves a nice, big smiley face. More recently, we talked about using division. And this is more close to what we're going to be doing today. To divide, so you're given an equation like this. Solve 3x equals 24. And remember, 3x is really 3 times x. So when we want to undo multiplication, we use the inverse operation, which is division. So we're going to use division. All right, so 3x equals 24. First thing you're going to do is divide both sides of the equation by 3. All right, so like we said before, we want to isolate this variable x. So I'll put a box around it to leave it there. But there's still that annoying 3 next to it. But it's multiplied by it. So to undo multiplication, you simply divide. So divide by 3. But again, if you do that to the left side of the equation, you must do it also to the right. So this would be divided by 3 as well. The nice thing about that is if you divide both sides by 3, it's also the same thing as multiplying by 1/3 if you look at it that way. You get a nice 1x on the left side. It has a coefficient of 1, but you don't have to list that one. Just so that you know it is a coefficient of 1 though. All right. Coefficient is something we talked about yesterday. Something that I think is really important. And the coefficient is just that number in front of the variable x. So if you divide it both by 3 on the left side, you get x, and divide 24 by 3 on the right side, you get 8. So we're saying x equals 8. So let's check it. We can put our box around that to say that's what we got. Let's check it by pulling it back into our original. All right, original was 3x equals 24. So plug it in. Let's put that x back in, that 8 back in for x. Then it's 3 times 8. Because remember, 3x is 3 times x. And 3 times 8 is equal to 24. So x is 8. All right, big smiley face there. And our answer is x equals 8. All right. So let's move on. I think we're pretty good there. Let's just move on to our new thing, which is using multiplication. The first thing I would like you to remember, though, I'd like you to know here is the multiplicative inverse. It's different. It is different than the additive inverse. The additive inverse, again, was just the opposite number. 14 would be negative 14. If you had, let's say, negative 12, the additive inverse would be 12. The multiplicative inverse is different because we're thinking of multiplication. So it's still going to be kind of an opposite, but this time it's the reciprocal of a number. All right, so if you remember the reciprocal, it's flipping the fraction. Right, when you multiply a number by its multiplicative inverse, it's going to get you to 1. Now we're getting to 1 instead of 0. So I'll give an example here. So we'll say a number. Let's just say 1/2. The multiplicative inverse, and I will show this to you. Is just flipping the fraction over. It's finding that reciprocal, which you hopefully know that the reciprocal are flipping it. Instead of 1 over 2, it's now 2 over 1. All right, that's the multiplicative inverse. If you're given, maybe you're given a whole number, because 2 over 1 is just 2. What if you're given 4 and you want to find the multiplicative inverse? 4 is just 4 over 1. So we can flip that around and say the multiplicative inverse would be 1 over 4. Let's try another one in green here. Let's say you're given negative 2/3. Now we know the reciprocal would be 3 over 2, but you still need that negative sign because when you multiply those two together, if you want it to equal 1, it has to be a positive number. It has to be a negative times a negative, because a negative times a positive would get you still a negative answer. So you have to do the total flip and leave that negative sign there. Okay, well, this is what we're going to use to solve equations when we want to multiply things. All right, so I'll show you an example here. This will be a real good one. All right, first off, we have solve 1/2 x, or 1/2 times x equals 8. We want to solve for x. So let's look for that variable, first of all, that we want to isolate. Let's put a box around x, because that's going to stay there. Now, we have that annoying 1/2 out in front. Now, if you are really good at dividing fractions, you can divide that both sides by 1/2, but that's a pain in the butt anyway, because you're going to have to use reciprocals, multiply by the reciprocals, and it's a whole pain in the butt when you divide fractions. So we're skipping a step, and we're going to use this multiplicative inverse idea. So if you look, let's say we had 1/2. The multiplicative inverse would be 2 over 1. So let's use that. All right? So we're going to use that to get rid of that coefficient of 1/2. So since the multiplicative inverse of 1/2 is 2, or 2 over 1, you can multiply both sides of the equation by 2. That's what we're doing. We're going to multiply this 1/2 fraction by 2, and we're going to do it to the other side as well, because when you multiply 1/2 by 2, those just cancel out. They become 1, and then it's just 1x, or x, which is really nice, because it's 2 over 2x, which is going to be 1x. Now you can simplify the right side, and you get 2 times 8, which is 16. And simplified version of 2 over 1, or 2 over 2x, you could say would be 1x, which we know then is just equal to x. All right, 2 over 2x is equal to 16, or x is equal to 16. But we still have to check our answer to see if our answer is correct. So we have to check our answer by, like we said earlier, substituting your solution into the original equation and simplifying. So let's do that. I believe it was done for us already. You can see here, we're plugging this in for x in our original equation. 1/2 times 16 is indeed 8. So 8 equals 8. And that's a good thing. Then we know that what we did was correct. All right, so the solution is correct. And I guess I added that in there. But 16 over 2 is equal to 8. 8 is equal to 8. So our solution really is, what we had in red here, x equals 16. All right, a little bit different than dividing. We're just going to multiply by the reciprocal to cancel that fraction out. Want to give you a tip on steps for solving an equation, especially really any equation. First thing you're going to do is always combine any like terms. Now, we haven't today had any that we had to combine like terms, so you can just go on. Check. All right, did the combining. Find the variable to isolate. So that's why I put a box around it, so you know what variable you're trying to get all by itself. All right. Step 3 would be to isolate that variable by using inverse operations. So if there's an addition on that side, you can subtract from it. There's multiplication on that side, you can divide from it. And if there's division or fraction on that side, we're going to use multiplication of the reciprocal to get rid of it. All right, so we're good there. Then you get your solution, and you have to check it by plugging back in. Once you check it, you can definitely give yourself a smiley face and be happy. So let us try just a couple examples here before we are done. All right, so this first one, now remember, find the variable that you want to isolate. So we're going to put that in a red box. I'm going to do all of these in a red box first of all, and we can skip that step then afterwards. All right, now we want to try and isolate that variable. So step 1, find the variable. Step 2, isolate. How are we going to isolate this variable? How are we going to get rid of that 1 over 3? Think of what we just talked about. we're going to multiply by its reciprocal. So, right here, the reciprocal of 3 over, or 1 over 3 is 3 over 1, just flipping it over. Do that to the right side as well so we can keep this thing balanced. If you do that, it's kind of nice. This will cancel out with that, that'll cancel out with that. You just left with 1, or really 3 over 3x, or 1x, because 3 over 3 is equal to 1, equals 7 times 3, and we know that 7 times 3 is equal to 21. So there we go. We got x equals 21. Step 3, though, is to always check your answer. Okay, so let's bring that back down. We had 1/3 x equals 7. Let's plug in for x right here. We'll do 1/3 times 21 equals 7. 1/3 of set 21 is 7, so it's like 21 divided by 3. 7 equals 7. Big smiley face. All right, that's how you go about this. It'll work every time. Make that smaller so we get it out of the way. And we can also make this whole thing smaller because we're going to go on and do the next one. All right, so the next one, we already found the variable to isolate. So find the variable to isolate, check. Isolate the variable. How are we going to isolate a variable when you have multiplication by a fraction? I know it's on the right side, but still going to do the same steps. Let's figure out what that reciprocal is and multiply by it. So the reciprocal of 2 over 5 would be 5 over 2. We'll do that over here as well. When you multiply that out, you get 2 times 5, which is 10. 5 times 2, which is 10. X equals 20. Multiply across. I'm not sure what happened there. Over 2 times 5, which is 10. All right. Now let's just simplify a little bit here. 10 over 10 is 1x. So I'm going to use a different color here just to note. That would be 1x, or just x. So that is equal to x. And over here, 20 divided by 10, divide 20 by 10, it's just 2. All right, x equals 2. That's good, but we can go ahead. Now we're going to check that off. Go ahead and check it. So if we have 4 over 5 equals 2 over 5x, or 2 over 5 times 2, you can multiply the tops here because that would be 2 over 1. 4 over 5 equals 4 over 5. Smiley face, because we got it. So our answer then is x equals 2. All right. So we talked about the multiplicative inverse of a fraction with a negative sign. So we're going to use that. You have to still have a negative sign there. Let's multiply this one. We will use multiplying by, again, this is going to be 3 over 1. So multiplying by 3 over, but it's a negative 3 over 1. So do that over here again as well, times negative 3 over 1. The nice thing about that would be it, because a negative times a negative makes it positive. 3 times 1 is 3. 1 times 3 is 3. X on that left side, because we're trying to isolate this x variable, equals 7 times negative 3 equals negative 21 over 1. Then we can just simplify 3 over 1 is to 1. or just x. That's what it is. It's 1x. And that equals negative 21. All right, we've got a solution. Let us check. So let's plug it back in for the original and say negative 1 over 3 times negative 21, or negative 21 over 1 equals 7. Negative 1 times 21 is 21 over 3 equals 7. And that is true. 21 divided by 3 is 7. That's equal to 7. Big whopping smiley face because you figured out that that works. So your value for this one is x equals 21. Negative 21, sorry. All right, so for tomorrow, all I want you to do is come up with one equation to solve try to make it one that will stump someone else at your table. So I'm gonna let you give it to a partner on Thursday, and I want to try to make it a tough one for someone else to solve, but that you still can solve. All right, so come up with an equation. Try to make it so that you can solve it, but so it's a little bit tough on someone else. And I want to see that come Thursday. So this was our video, solving equations using multiplication, and we did that. We multiplied by that multiplicative inverse. All right, until next time, have a good one.